Hi, this is Kumar. Today I am going to discuss about DES algorithm. Before discussing the DES algorithm, let me discuss about the basic concept in cryptography. Consider there is a network. So there are various nodes, namely A and B. So these two nodes are going to communicate with each other by using a communication channel. And there are attackers in the networks, which is nothing but C. His main task is to monitor the network traffic. So monitoring the network traffic by using the network traffic load, what the attacker will do is attacker will perform an attack. He just sniffed into the network and get the data which was sent by the A. Initially, the A uses substitution and transposition technique to encrypt the data. So the techniques are having vulnerabilities. Why? Because the attacker will easily get the data. To avoid this, we are introducing a concept called DES algorithm. DES algorithm. It is mainly used for encryption and decryption. It accepts 64-bit plain text, it uses 64-bit key, it uses physical network for round computation. For computing rounds, it uses the physical network. And one more thing I would like to discuss here is in DES it uses block cipher mechanism. We have two types of mechanisms here, block cipher and stream cipher. So as I already told, in the networks, A wants to transmit the data to B. A uses the substitution or transposition technique. So those techniques are stream ciphers. Stream ciphers means it encrypts the data character by character, whereas when coming to the block cipher, it encrypts the data blockwise. So block size may be 32-bit or 48-bit or 64-bit or 128-bit. So depending upon the algorithm which we are going to use. So here the DES will accept the 64-bit as a plain text and it uses 64-bit as a key. So by using these parameters, how we will encrypt the data. So let me discuss the thing. Now I am going to discuss about the general structure of the DES algorithm. So the general structure looks like structure of the DES. The general structure looks like this is the plain text of size 64-bit and perform initial permutation. IB is nothing but initial permutation. Initial permutation is nothing but changing the bit positions of the initial plain text. Changing the bit positions of initial plain text. Then afterwards, we can apply a round function. This is what's called as a round function. Then we perform XOR operation with this. And it will get the K as an input. Let me discuss this structure first. This is the main heart of the DES. So the DES will perform 16 rounds. So this is the single round. So it loops until it performs 16 rounds. So what the function will include is, the function will be described by apply Feastal network on IP, which is nothing but this is the IP, and we have to apply Feastal network structure. So how the Feastal network structure looks like is, it divides the IP into two equal parts, which is L0 and R0, which is of size 32 bit. Totally we will get 64 IP, which is of, so take R0 and perform expansion box, which leads to, we will get the 32 bit as a 48 bit. 32 bit as a 48 bit. Then input K, initially K is of size, K is nothing but a key. K is of size 64 bit. And we perform parity dropper here. We'll get the 56 bit as a key by applying parity dropper on initial input key. We will get the 56 bit as a key. Then we reduce it to 48 bit by applying compression debox here, which is nothing but compression debox. For getting the 56 bit into 48 bit, we will apply compression debox on the key. Before applying compression debox, we will apply shift operation, which is nothing but left shift of 1 bit. We have a schedule called key schedule. Key schedule 1, 2, 9, 16. These are all the rounds. And shifted bits. This is what's called as a shifted bits. Means we have to left shift the number of bits. Here it is 1 bit. And remaining other rounds, which is nothing but 3, 4, 5, 6, 7, 8, 10, remaining so on. These are of 2 bits. We will this is the single round. We are in single round, so that's why we will. So this is the first round. First round we will shift by 1 bit. So we will left shift by 1 bit. Then we will input this 48 bit into. We apply compression debox. Compression debox, what it does is, it gives a permutation which is of size 48 bit. 48 bit. It avoids the bit positions of 9, 18, 22, 25, 35, 38, 43, 54. It avoids all these bit positions 1, 2, 3, 4, 5, 6, 7, 8. From the parity dropper, it avoids all these bit positions. Then it will get the permutation matrix. That matrix is to be inputted to the expansion box of 48 bit. Here, let me discuss one more point, is how to expand the 32 bit as a 48 bit. Consider this is the R0. and it is of size 32 bit. One indexes are 1, 2, 3, 4, and we will make this into equal parts, 8 equal parts. 8 equal parts. So these 8 equal parts indexes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on up to 32. So the last R0 is of size 32 bit, so on 32. So the expansion is, it will expand the 4-bit block into 6-bit block. 4-bit block into 6-bit block. So the first bit will be replaced by the 32nd bit of the R0. So this is called R0. So R0, so that is first 32. Then we will, as it is, copy the first bit as a second bit, and second bit as the third bit, and third bit as the fourth bit, and fourth bit as the fifth bit, and fifth bit as the sixth bit. This is the block, and the next block will get the first block last bit is getting into the second block first bit, and 5 will be as it is 5, 6, 7, 8, and the later the 9 will comes here. So this is the second bit. So totally is of size 6 bits. So the process is continuous until the last, up to last. So we will expand here 6 into 8, which is nothing but 48 bit. This 48 bit is going to XOR with compression debox 48 bit. So it is going to perform an XOR operation here. After completion of XOR operation, so this is R0, and we have applied a function here. Function will produce an output. That output is going to XOR with the L0 block, and here also this function. After performing XOR operation, the R0 bit this is L0, sorry, this is L1 and this is R1. See, this is the general structure, and here a key. In this function we already discussed about the compression debox and expansion. Will get the XOR will perform XOR operation. After performing XOR operation here, the lookup table is existence. Lookup table, which is nothing but a substitution box. Substitution box is, the main advantage of this substitution box is for confusion and diffusion purpose. The attacker, if he wants to reveals the data, then he automatically get confused which bit position has to be changed. So that is the main advantage of this substitution box. So we have 8 substitution boxes. 8 substitution boxes, and each substitution boxes will accept 6 bits as an input and 4 bits as an output. So together we have totally 8 S boxes and inputs are 8 into 6, which is nothing but 48 bit as an input, and we will get the 32 bit. Totally we will get four outputs of each block. So together we will constitute as an 32 bit as an output. This 32 bit is nothing but this 32 bit. This is the 32 bit, and we are going to perform XOR operation with the L0. So L0 is also having the 32 bit. So that 32 bit and this 32 bit will get into R1. So I will construct a formula for this. So here the R1 is equals to function of R0 plus K XOR with L0. XOR with L0. So these are all the XOR operations. Then compute L1. L1 equals to directly R0. L1 equals to directly R0. So this is the formula which we are going to obtain from this particular structure of the DES. Then coming to the point of substitution box. I already told you that the substitution box accepts the 6 bit as an input. So here the key is of 48 bit. After performing the XOR operation for keep and R0, this step, key and R0, thus we will get the substitution box inputted structure. So S box, it accepts the, so first S box will have the rows and columns. So first take the first 6 bits, something like for example, so 11, 111, 000 is the example which we are going to take for the S box 1. So these are all the first 6 bits. So these first pick up the first bit and the last bit. So it is 1 and 0. So S box 1, this is S box 1. So it have a row of 0 0 0 1 1 0 1 1 1 0 1 1, and columns are 0 0 0 0 0 0 1 0 and 0 0 1 1 and 0 1 0 0, so on 1 1 1 1 up to 15, 0 to 15. So this is the lookup table. So we have 1 and 0. So this is the 1 and 0, and we have the remaining bits are 1 1 0 0. So look the 1 1 0 0 something around here. So you will get the value of some, for example, it shows the value of 16 or 10. It shows the value of 10. So the 10 value will be represented in binary is 1010. So 1010 as output. So S box 1 is generating the output of 1010. So that is the 4 bit. So for same as it is like next 6 bits. S box 2. S box 2 will be here. Same, the rows are 0 0 0 1 1 0 1 1 and up to 0 to 15. Same, S3, S4, S5, S6, S7, S8. So these are all mainly used for the purpose of confusion and diffusion of the attacker, where the attacker will not easily perform the attack or not unable to get the data very easily. So this is how the S box will work, and after completion of this, again it perform one more round. So here, if you carefully observe the structure, this is what's called as a swapper. Not swapper, this is called as a mixer, and this is what's called as a swapper here. Here it is swapping, means left to right and right to left, right to left and left to right. So this is what's called as a swapper. So the DES will uses 16 mixers and 16 swappers for computing a plain text into ciphertext. And whereas when coming to the point of decryption, decryption is nothing but the process of converting the ciphertext. We will get the ciphertext here, and before getting the ciphertext, we will perform a final permutation here, FP, which is nothing but final permutation. So final permutation is of size 64 bit. We are combining L15 and R15 into together, and we will get the 64 bit ciphertext, and we apply FP on that. FP is nothing but final permutation. So it is also a defined permutation matrix, so where we can change the bit positions of the ciphertext. Thus we will get the ciphertext as a 64 bit. Then at the receiver end, what it do is, receiver will do decryption. So he can have the same key. So the key which is used in encryption is the same key which is used in decryption also. So that is what's called as a symmetric key encryption. Then coming to the point of advantages of DES. Advantages of DES is avalanche effect. Avalanche effect. What it tells is, if there is any change in the plain text or key, then there is a similar change. Then there is a substantial change in the ciphertext. So means if I change any plain text, if I change any bit in a plain text, then it will give the different ciphertext. The next, the one more advantage is S-boxes. S-boxes, what it does is, I already told you that it will confuse the attacker to decrypt the ciphertext. So the next, the disadvantage is brute force attack will be possible by DES. Brute force attack. So the ciphertext will be revealed by 2 power 55 combinations. So it has some limit. So if attacker performs 2 power 55 combinations of plain text and key, so then automatically he will decrypt the plain text. So that is one of the greater brute force attack. To countermeasure this, we are applying triple DES. So triple DES is the one more encryption algorithm. So it countermeasures the brute force attack. Why? Because it is not possible for the attacker to decrypt the ciphertext. So this is how the DES will work. Thank you.